All right, question 3 gets a little more interesting. We need to calculate the power requirements of a 1400 kilogram car under 2 different circumstances. So our car is 1400 kilograms, and in part A, it's just going up up the hill at a steady speed. Steady speed, what does that say to you? Steady speed says to me A equals 0. In other words, sum of the forces equals 0. Okay, so we need to basically, let's draw a free body diagram here. We need to figure out how we can make this work. We know that there's a force of gravity pulling it down. We know there's some kind of force overcoming that, some applied force of the car. We also know there's a backward force of friction, and they give us a number here. It's 700 newtons, and obviously there's also this normal force, Fn, perpendicular to the slope. So this stuff is from last unit. It should be a little more straightforward to you, but looking along the slope, we can see that MA equals the sum of the forces. So 0 equals, now the sum of the forces is going to be FA minus the force of friction minus the x component of gravity. And so then the applied force that's going to have to be put on this car is just going to be the force of friction plus the x component of gravity. So we have this as 700 plus, and then this would be mg, m times g times the sine of 10. And you can look at the triangle and remember stuff from last unit to figure that out. So FA equals that. Plugging all those numbers in, 700 plus 1400 times 9.8 times sine of 10. And what we get for our applied force is going to be 3100 newtons. Let's just do it quickly. Bear with me. 700 plus 1400. Here, I'll do it like this. So, no, you can't see that. 700 plus 1400 times 9.8 times the sine of 10. And that's going to equal 3082. It's a terrible calculator. 3082.45 newtons. Okay, so then what do we do with that? Well, we also have another form of the equation, power equals, and we have it on the worksheet, it's F times the average speed, right? And they tell us the average speed, it's 80 kilometers an hour. V is 80 kilometers, oops, not kilograms, kilometers per hour, which remember, we can't use kilometers per hour, it's got to get converted into meters per second. So 80 divided by 3.6 is going to give us 22.2 meters per second. So then now it's just plugging it in. So 3082.45 times 22.22, and we get times 82.45, and we end up with 68,000 basically. The answers on the worksheet are all done to correct significant digits, but the answer you actually get here is 68,498.8, so 499 watts. And if you think about that's too many digits, we don't really know it that accurately. So we can round this to well, it's 499, but so I guess we would round this to 6,800. It would round down. So 6,800. One way to write that is 6,800 watts, or a better way to write it probably is 6.8 times 10 to the 4 watts, which is what it says on the worksheet. So that's the answer, and that's how you get it. I'll do another video for part B.